Today, let us try to understand what is performance of an IC engine and the various parameters that affect the performance of an IC engine. Engine performance is the ability of an engine to perform the task assigned to it, and the task of an engine is convert the chemical energy present in fuel into useful mechanical work. For the engine to perform properly, some of the parameters that affect the engine performance are indicated power, brake power, mechanical efficiency, specific fuel consumption, volumetric efficiency, fuel-air ratio, thermal efficiency, and heat balance sheet. Now, let us try to understand what each of these terms means. Let us try to define them and find out how to calculate these parameters. The first one is the indicated power. It is the power developed inside the engine cylinder. It is calculated by the equation IP is equal to PM LA/Nk by 60,000, where PM is the mean effective pressure based on the indicator diagram. Then small a is the area of the indicator diagram, small l is the length of the indicator diagram, and S is the spring rate. Capital L is the stroke length in meters, capital A is the cross section area of the piston or cylinder in meter square, small n is the number of power strokes. If it is a two-stroke cycle, small n is equal to capital N, that is the number of revolutions of the crankshaft, and for four-stroke cycle, the number of power strokes will be half the number of revolutions of the crankshaft. K is the number of cylinders. Number 2, brake power. It is the power which is available at the crankshaft. It is calculated by the equation Vp equal to 2 pi Nt by 60,000 kilowatts, where N is the RPM of the crankshaft. T is the torque. If it is a rope brake dynamometer, it is calculated by W minus S into T plus dr by 2, where W is the load in newtons, S is the spring load in newtons, capital D the brake drum diameter, and D suffix R the rope diameter. If it is a Prony brake, torque is calculated by W into L, where W is the load in newtons, L is the effort arm. Third parameter is the mechanical efficiency. It is the ratio of brake power to indicated power. The next parameter we study is the specific fuel consumption. We have two types of specific fuel consumptions. One is based on the brake power, the other one is based on the indicated power. Brake specific fuel consumption is the ratio of fuel consumed to produce unit brake power. Indicated specific fuel consumption is the ratio of mass of fuel to the indicated power. MF represents the fuel consumption in kg per hour. BP and IP being in kilowatts. So the units for BSFC and ISFC is kg per kilowatt hour. Volumetric efficiency. It is a ratio of actual volume of air admitted into the cylinder to the swept volume. Fuel-air ratio. It is a ratio of mass of fuel to the mass of air. Thermal efficiency. Here again, we have one based on the brake power, the other one on the indicated power. Brake thermal efficiency is the ratio of brake power to the amount of heat supplied by combustion of fuel. So the equation will be Vp into 3600 divided by Mf into C. Indicated thermal efficiency is the ratio of indicated power to the heat supplied in the form of combustion of fuel. The equation will be IP into 3600 divided by MF into C. Lastly, we see heat balance sheet. It is a sheet which presents the heat that is being supplied per minute to the engine cylinder and how this heat is utilized for various reasons per minute.